Hey, what's going on, guys? We're back with another video. Today we're going to go over 7.1, which is integration by parts. Okay, so we're going to go ahead and start with is to go ahead and write out what is the actual formula for the integration by parts. We're going to start off with the integral of u dv, which is equal to u v minus the integral of v du. Now this is something that we're going to have to go ahead and memorize. We're each going to go ahead and try to grab these integrals, convert them as they're not already into products or multiplication, and we're going to go ahead and have to figure out which one's going to be u and which one's going to be dv, and fill in the rest of the equation. So like I always said, let's go ahead and start it off with an example. Let's go ahead and write this example out. The integral of x ex dx. Okay, so if you want to go ahead and take some time to pause the video and do it on your own, I would suggest it, and push play whenever you have the answer and see how we did it and see if your answer matches with the answer that we get at the end. Okay, so the first thing we have to do is, it's already a multiplication, right? There's already x times e to the x. And now we got to go ahead and pick which one will be the derivative and which one will be the non-derivative. Meaning, if we do u, we're going to go ahead and take the derivative of that to get a du, because that's what our formula has on this side. And if we pick one to be dv, we're going to take the integral of that and the opposite side and to get v, because that's what our formula has inside this integral. So what we have to go ahead and look forward is, we have a product. Now if we pick one to be a certain variable, like for example, if we happen to pick x to be dv, right? So dv equals x, and let's say u equals e to the x. Well, we're going to take the derivative of the u, so it's going to be du over dx is equal to, and the derivative of e to the x is just e to the x. So then we're going to go ahead and just say du is equal to e to the x dx. Now for this one, we're going to go ahead and take the integral of both sides. Okay, and when we take the integral of both sides, and this is going to be a dx on this side, because that's what's left over from our original equation, we have a v on this side, and we have x squared over 2. Okay, so if we go ahead and put that into our formula, we have this whole thing equals, and we have u, which is e to the x, we have v, which is x squared over 2, minus the integral of v, which is x squared over 2, du, and du is e to the x dx. Now, see what we got here, or see what had happened was, we had originally started with x times e to the x. When we're trying to use this rule, we're trying to go ahead and simplify it and find a way where we can find integrals of things. Well, the thing is, we don't need to find an integral of this anymore because there is no integral. But we have an integral on this side. And this almost resembles what we had. The only difference is now we have more x's. We have an x squared and a 1/2. So, and it's still a multiplication. So the issue is, if we were to do it again, and this time we would go ahead and select u to be x, we would probably fall back to our original equation. So in this case, if you were to go to that step, the right way to have done this was allow x to be our u. So if we go back, we're going to go ahead and allow x to be our u, because as you can see, it wasn't allowing us to basically simplify an integral in a lot easier sense. If the integral had an addition, And there it'd be a lot easier to take the integral of one side of the addition, the integral of the other side of the addition, and we're done with that. But we take the integral of a product rule again, we got to do integration by parts once again. And there's going to be many times we're going to have to do integration by parts multiple times. So in this problem, let's go ahead and set u equal to x and dv equal to whatever's left inside of our original integral, which is e to the x dx. So we take the derivative, it'll be du is equal to the derivative of x is just 1 dx. So in the sense, du is equal to dx. Now, when it comes to this side, dv, we take the integral, we're left with v on the left side. The integral of e to the x, well, what derivative gives you e to the x? Well, e to the x. If you take the derivative of e to the x, it gives you e to the x. If you take the antiderivative of e to the x, it also gives you e to the x. So what we can do now is we can set this whole thing equal to what our equation states, u, which is x, v, which is e to the x, minus the integral of v, which is e to the x, du, and du is just dx. So now, this is a lot easier to take an integral out of because we don't have a multiplication where we may need an integration by parts. So we're going to be left with x e to the x minus the integral of e to the x. Well, we had already established that here, which is basically just e to the x plus some type of constant. So in theory, our integral of x e to the x dx is equal to, when we find the integral of that, it is x e to the x minus e to the x plus some type of constant. And that'll be our answer. Okay, so it does depend on what you set u equal to and dv equal to. There are some cases where it doesn't matter. Whichever one you select, you're going to get almost the same outcome. But in this case, since we originally had set u to be e to the x and dv to be x, when we took the integral of the x, it actually gave us 1/2 x squared, which gave us more x's. So in this case, it's always easier to set a lot of your just variables to be u because honestly, it cancels them out. If we would have had x squared, we probably would have had to use integration by parts twice because we know that the first derivative would have made this squared into an x, and if we would have taken the integral again, we would have taken the derivative once again, that x, if you take the derivative of just x, it'll turn it into just 1. So let's go ahead and do some more problems. I know sometimes it gets confusing and I get confused as well, but let's go ahead and do some more problems on these. So another example is going to be the integral of x ln of x dx. Okay, so this case, it should be a little more obvious on what we should set x equal to and what we should set our dv equal to. If we let our u equal x, right? When we take the derivative of that, we're going to be left with basically du equals dx. But if we let our dv equal to ln of x dx, and we take the integral of both of these, we know the integral of dv is v, but we don't know what the integral of ln of x is. That's actually something that, we haven't really found to be. I'm sure there's an answer, but it's not the answer that we always think of, because what we know is that if we take the derivative, if we take the integral of 1 over x, that gives us ln of x. right? And if we take the derivative of ln of x, that usually gives us 1 over x. But in this case, if we take the integral of ln of x, that doesn't give us 1 over x. So in this case, it actually does matter on what we set our u to be. So in this case, if we set our u to equal to ln of x and our dv to equal x, then we can go ahead and du is equal to 1 over x dx, and then our take the integral of both of these, our v is equal to x squared over 2. Now, if we go ahead and put into the original formula that we had, it was this whole thing equals u, which is ln of x, v, which is going to be 1/2 x squared, minus the integral of v, which is x squared over 2 du. Okay. Du is 1 over x dx. So as we can see here, we're going to go ahead and rewrite this a little bit nicer. We have ln of x squared minus, well, here we have x squared and we have an x. Those can cancel. And we're left with basically x over 2. So it's the integral of x over 2 dx, which then we can do is we can go ahead and rewrite this a little nicer again. ln of x squared minus, let's throw the 1/2 in the front, and we're left with x dx. Now this is very easy to take the integral of, and we take the integral of that, which is just going to be x squared over 2, and then we still have it being multiplied by negative 1/2, and then we still have all of this brought down. Now, and then we're going to have some type of constant here, so we're going to have one-half ln x squared, or let me go ahead and rewrite it like this, x squared there, minus 1/4 x squared plus c. So this is our answer for the integral of x times ln of x. Okay, so like I said, it's not too difficult. It does start to get difficult, and when it does start to get difficult, then that's when we can go ahead and think about these things a little more clearly. But let's go ahead and try to work on another example. So another example is going to be x squared sine of x dx. Now go ahead and pause the video and let me know if you guys can solve it and what your answer is. If you guys can, hopefully it resembles what we get, and if it doesn't, then maybe it could have been that you didn't set u or dv to the right one, and I would redo it. But let's go ahead and figure this out. So I think this kind of resembles one of our first problems. If you remember, I think it was x originated here instead of an x squared. So in this sense, if we were to take the derivative of this side, what would we get? Well, sine gives us cosine, right? So it doesn't really matter if we take, u to be sine. But if we set it to equal x squared, if we take the derivative of x squared, it actually gives us 2x. And if it gives us 2x, that means this power actually decreased. So what we can do is we're going to go ahead and set x squared to equal to u. So if we set that our u to equal x squared, our dv is going to equal to sine of x dx. Alright, so we take the derivative of this side, it's going to equal 2x dx. If we take the integral of these sides, decrease the size of that, then we're going to have v is equal to, well, sine gives us cosine, and cosine gives us negative sine. This must give us negative cosine of x. Okay, so now if we put that into our formula, we have this whole thing equals u, which is x squared, v, which is negative cosine, so negative cosine of x, minus the integral of u, v du. So v du, which is 2x dx. Now, as you can see here, we have another multiplication. So what we can do now is we can first off is get rid of that negative that's in the inside, which would be negative squared cosine of x plus the integral of cosine of x to x dx. So what we're left in that integral is still a product or a multiplication. So what we're going to have to do here is integration by parts again. So as you can see here, you might have to do it multiple times. So if we bring this whole thing down, we have negative x squared cosine of x plus, well, in this case, which one will we set u equal to, and which one we set dv equal to? And like I stated earlier, this power went from x2 to x1, or just x. So the exponent went from 2 to 1, so it decreased. So if we go ahead and set u to equal to 2x and our dv to equal to cosine of x dx, and we take the integral of these sides, we're going to have v on this side, and if sine gives us cosine, then this is going to turn into a sine of x. And if we take the derivative of this side, we're going to be left with 2 dx. Okay, so then what we can do is we're going to go ahead and grab this, we're going to bring it down, and then we're going to have u, which is 2x, v, which is sine of x, minus the integral, which is going to be v, sine of x, times du, which is 2 dx. So what we can do here is we can go ahead and now take the integral of this thing, because it's a lot easier to take the integral of that now. So equals negative x squared cosine of x plus 2x sine of x minus 2, I'm going to take the 2 out of the integral, sine of x dx. So what we're going to be left with is negative x squared cosine of x plus 2x sine of x minus 2, and then the integral of sine of x, well, if we know that sine gives us cosine, cosine gives us negative sine, and actually if we throw the negative back in there, or if we know that cosine gives us negative sine, then we must know that this is going to be negative cosine of x plus some type of constant. So to go ahead and wrap it all up, we're going to go ahead and have negative x squared cosine of x plus 2x sine of x plus 2 cosine of x, okay, minus c. And then we know that this is just a constant, right? So if we take negative c and we let that equal d, then it can be negative x squared cosine of x plus 2x sine of x plus 2 cosine of x plus d. I mean, in reality, the constant doesn't really matter much because, I mean, we don't really know what that constant is. We don't know if it could be negative, it could be positive, it could be a negative number. So, for example, if we have negative times a negative number, it could still be positive. So we really don't know what that is. So sometimes you just end up writing it plus c all the time. It just depends on how your instructor likes to do it. You could leave it as negative c. Like I said, it doesn't really matter. But basically, these two are your solutions for that integral. So those are the those are the three problems that you can kind of face. There are some other problems. For example, there's one that I would really want to go over with, only because sometimes you might do the integration by parts, and when you do the integration by parts, you might end up getting the same thing that you started with, and you can end up just adding or subtracting it to the other side. Okay, so let's go ahead and go over this problem. So example number 4, I believe. So the integral of e to the 6x cosine of 2x dx. So in this case, so which one will we set u or dv to equal to? So it's really difficult to go ahead and try. I mean, in this case, it's cosine of 2x. A lot of us know what the cosine of x, or the derivative or the integral of cosine of x is. So in this case, I would say the best option that we can do is set u equal to e to the 6x. dv is going to equal to cosine of 2x dx. Okay, so if we have du is going to equal to, when we take the derivative, it's going to be e6x, and then we have to go ahead and think about the chain rule there. So if we think about taking the derivative of just 6x, it gives us 6. So we got to go ahead and now take the integral of both sides. We're going to have v is equal to, well, if we go ahead and, in this case, I can tell you what it's going to give you. It's going to give you 1/2 sine of 2x, right? Because sine gives us cosine, so then cosine of 2x. But the thing is, we have an extra 1/2 because of the possible chain rule. But if you don't know that this is what's going to give you, especially when you have a 2 in here, just remember rule of thumb that if you have, let's say for example, cosine of 6x, and you're taking the integral of that, then you know that your integral of that is going to be, of course, sine of 6x, right? But you're going to be left with a 1/6 in the front. So the formula, 6x, that I would have you guys remember is it's going to be 1 over a of, say, cosine of a to the x. Okay, but if you guys don't know that and you guys don't remember that, and also it can also depend on if you have a cosine of 2x or a sine of x, or 2x, I mean, you can go ahead and just basically do a normal u substitution. So if you want to go ahead and do a u substitution, you would do the integral of cosine of basically u, and then what we have to do is we're going to have u is equal to 2x. Well, du is equal to 2 dx. du over 2 is equal to dx. And now we're going to have integral of cosine of u, and then substitute the 2x back in, and that's going to go ahead and gives us du to the 1/2 in front. And then now we have 1/2 integral cosine of u, let's just go ahead and put everything back in, of 2x, I'm sorry, let's do the integral of it. So cosine gives you, sine gives you cosine, so that's going to give us sine of u plus some type of constant, which doesn't really matter at this moment in time. And then we're going to have 1/2, and that's going to be sine, and then we plug that back in, and we have 2x plus some type of constant. And as you can see, they're the same. So like I said, if you ever have something like the 2x in there and you don't know, or 3x or 9x or whatever x in there, you can go ahead and just do a normal u substitution to figure out what is your integral for that one. Okay, so go ahead and erase this. So now that we know what our values are, we can go ahead and put it into the formula. So we're going to have u, which is e to the 6x, v, which is 1/2 sine of 2x, minus the integral of 1/2, which is v du, sine of x, sine of 2x, and du is e to the 6x. Actually 6, because this is a 6 here. Okay, and then this is dx here. We always have a dx there. Make that a little nicer, times 6 dx. So, as you can see, we still have a product rule here. So, we're most likely going to have to do another integration by parts. Doesn't mean that we're doing it wrong, but we still have an ex. And now we have, instead of a cosine that we started, we have a sine. But we know that if we, this time, if we go ahead and take the integral of a sine of 2x, we're definitely going to get another cosine. So in a sense, and we take the derivative of e to the 6x, or 6e to the 6x, we're going to get at least an e to the 6x back. So in a sense, if we take another integration by parts, we possibly could get our formula back, or our original equation back. So let's go ahead and do that. So let's say equals 1/2 e to the 6x sine 2x minus, so let's go ahead and do which set 1 to equal to u and 1 to equal to dv. So we said we're going to set our ex back to equal to u. So if u is going to equal to 6e to the 6x du is going to equal to 6e to the 6x times 6, which basically is just going to give us 36, I believe. So it's going to be du is equal to 36e to the 6x. Now, if we go ahead and set our v to equal to 1/2, actually, you know what? Let me go ahead and rewrite this a little differently, because I didn't notice that we can actually simplify here. So we have a 6 and a 1/2. If we go ahead and simplify that, it'll actually make our life a lot easier. And we're going to end up having 3, and we'll pull that out, of sine 2x e to the 6x dx. Because we took this 6 and the 1/2 and we multiplied it together, that gives us 6 over 2, which is 3. And we just go ahead and pull that out to start with, because it's going to make things a little bit easier and not so messy when we go ahead and do integration by parts. So now if we set our u equal to e to the 6x, and our dv equal to sine of 2x dx. Well, du is equal to, like we had already established before, to be 6e to the 6x dx, and v is going to equal to 1/2. And if sine, well, we're first going to take the integral. If sine gives us cosine, then cosine gives us negative sine. So we're going to have negative 1/2 of cosine of 2x. Okay. So we're going to go ahead and plug that all back in. So then if we have equals 1/2 e to the 6x sine of 2x minus 3. And now we're going to go ahead and put that into a bracket, and we're going to have u, which is e to the 6x, times v, which is going to be times 1/2 cosine of 2x minus the integral of, and it's going to be v du, which is pull the 1/2 in front. Oops. Minus the integral of negative 1/2 cosine of 2x, and du is 6 e to the 6x dx. If you look at it, our original equation was e to the 6x cosine of 2x, and we have an e to the 6x multiplied by cosine of 2x. So let's go ahead and simplify this a little bit more. So we have equals to 1/2 e to the 6x sine of 2x minus 3. And then if we actually just throw that in there, then we're going to have, well, first let me just do this, e 6x times 1/2, and this should be actually negative, okay, because we had our negative here, cosine of 2x minus, well, again, we have 1/2, negative 1/2, and 6. So multiply those, we're going to get a negative 3. We pull that out, and you get a positive 3 integral of, let me go ahead and rewrite this because it doesn't matter how you write a product. It could be cosine of 2x times e to the x, or it could be e to the 6x times cosine of 2x. So we're going to write it e to the 6x cosine of 2x dx. Okay, and as you can see here, looks exactly like it does here. So what we can actually do now is, if we distribute that 3 in there, we have 1/2 e to the 6x sine of 2x minus 3 e to the 6x times 1/2, or let me just go ahead and erase that 1/2 and put it over here. And negative is going to become a positive here, because we're going to have negative 3 times negative 1/2, which is positive 3 over 2 e to 6x cosine of 2x. Negative 3 times negative 3 is negative 9 integral of e to the 6x cosine of 2x dx. Well, if we know that e to the 6x cosine of 2x dx is equal to all of that, what we can actually do is we can actually add 9 integral e to the 6x cosine of 2x dx. These cancel out. Think of it as all of the right to the 9 is a variable, like having 9a. So we have negative 9a, we add them to both sides, and on this side we have just a. So what we're going to do is we're going to add 9, because this is going to have a 1 on the outside, integral of e to the 6x cosine of 2x dx. That'll give us 10 integral of e to the 6x cosine of 2x dx is equal to, and now we're going to go ahead and rewrite all that stuff. So we're going to have 1/2 e to the 6x sine of 2x plus 3/2 e to the 6x cosine of 2x, okay, plus some type of constant, right? You're always going to have some type of constant floating around there. So what we're going to end up having is we have to go ahead and multiply this whole thing by, or divide, but I'm just going to go ahead and multiply it by 1/10. That's going to cancel these two out, and we're going to be left with, on the left side, integral of e to the 6x cosine of 2x dx is equal to, so we have to multiply this whole thing by 1/10. So we're going to have 1/20 e to the 6x sine of 2x plus 3/20 e to the 6x cosine of 2x plus some type of constant. So what we have concluded is that this value is going to be the integral of e to the 6x cosine of 2x. So these are the most trickier ones, especially when you're picking a u or picking a dv. You have to go ahead and try to figure out which is the one that is going to actually get you to eliminate that product rule. Like we had seen earlier, we had seen that some that are exponents on some of them actually decrease. In this case, e to the 6x, if you take the integral of that or take the derivative of that, it's always going to give you e to the 6x no matter what. Hope this was helpful. I'll see you guys on the next video.